In this video, I will show you how to set up copper catalyzed electrochemical alkene difunctionalization reaction. Here's the model reaction we will be working with, and these are the chemicals needed for this reaction. We use a sling flask to set up this reaction. First, we keep it under vacuum. And here is the electrode setup. So we use two glassy carbon electrodes as the anode and cathode for this reaction. We set up the reaction under an argon atmosphere. Here I am turning on the argon flow, and you can see the gas flowing through. First I add the solid reactant. This is lithium perchlorate. Followed by the copper catalyst. So the copper catalyst is stored in the glove box and I take it out from there before use. After adding the solids, I keep the flask under vacuum for a few minutes before adding the remaining reactants. Once the vacuum is done, we turn on the argon flow back again and start adding the remaining reagents. First, add the alkene. Then triethylamine. Next, I add the solvent acetonitrile. And stir the solution until everything dissolves completely. After that, we add the final reagent, which is triple chloride. So this one is air sensitive, so it's also stored in the glove box and should be taken out just before adding it to the reaction. Now we place the pair of glassy carbon electrodes like this and seal this flask with paraffin. Next, it's time to apply the electricity. So this reaction runs under constant voltage. Here's the waveform generator. I use this to apply the constant voltage. Under the utility menu, you can turn on the DC mode. So the reaction operates at 2.5 volts. So I set the voltage to 1.25 volt, and you can see the amplifier output. So this is the amplifier and it's showing 2.50 volt. You can adjust it accordingly. So once everything is ready, I connect the output to the reaction using BNC cable and let it run for about 24 hours. After setting it up, I seal the sling flask and turn off the argon flow. After 24 hours, I add hexafluorobenzene as an internal standard and perform fluorine NMR analysis. You can also run TLC to double check that the reaction is complete.